In this video, we are going to perform a pen test on a target machine. It's also kind of like a CDF, but we are going to look all of the phases that comes along in a pen test. So yeah, let's get started. First, I want you to know that the target machine is also in the same network as of my Kali machine, which is the attacker machine. But I don't know the IP address of the target machine, so the first step in the pen test would be host discovery. In host discovery, we're trying to find the IP address of the target machine, and we can do that with the help of Nmap. But before we do that, we need to know the network address. To find the network address, I'm going to type in ifconfig, and as you can see in the ETH0 interface, I can see my IP address. But over here, 1003 is the network address and 5 is my Linux IP address. So 1003 is the network address, and after that we are going to enumerate for all the possible numbers or IP addresses, and if there are any live hosts, we should be able to see that on the screen. So I'm going to type in nmap-sn to not scan for ports, and then the network address, which is 1003 and then .0/24. It basically tells the nmap to scan for all the 255 possible hosts and print the live ones on the screen. So as we can see, there are 3 hosts that are up: 1, 5, and 6. Since we know that the 10035 is our own Linux IP address, we can start scanning in the 10031, and let's check if it is a target IP. So I'm going to scan for services. And as you can see, it doesn't have anything special, so this is not the target IP. Let's scan for the last one, which is 10.0.3.6. And we found it. So there are 2 ports open, port 80 and port 22, which is running SSH. Now, since we know that this is a target IP address, we can scan a little bit deep. So I'm going to clear the screen up, and over here I'm going to do an aggressive scan, and I'm going to run some default Nmap scripts. Okay, so it shows us that it is running Apache 2.4.48, and we can also see that there is robots.txt file, and there is one disallowed entry, that is my files. So let's check it out in the browser. And it says error 404. So nothing interesting, I guess. What we can do now is to enumerate for directories and files. So we can do that with the help of FUF tool. Here I'm gonna give the path of the word list, which is in my sec list, and then the IP address. After waiting for a while, we didn't find anything, which is weird. Maybe because we were enumerating it in the wrong way. From the file we discovered in robots.txt, we saw a tilde before the name of the file. Maybe all the files start with that symbol. So I'm going to change the command a little bit and start enumerating for files or directories again. So I'm going to provide the symbol before the fuzz word and start the enumeration again. And we got a file with 301 status code secret. Let's check this out in the browser. and it does look interesting. It says, "Hello friend, I'm happy that you found my secret directory. I created this file to share you my private SSH private key file. It's hidden somewhere here so that hackers don't find it and crack my passphrase with fast track. Okay, your best friend IceX64." Yeah, and that's why I said it's kind of like a CDF. It's revealing a lot of information here. The first thing it reveals that there is a SSH private key file and it's over here in the server. So if we enumerate more, we maybe can find it. The second thing it reveals that we can crack the passphrase with the fast track. Means the SSH private key is probably logged with the passphrase. And the third thing it reveals is that the username is IceX64. Okay, that's a lot of information. Now let's start enumerating again to find that SSH private key file. Back in the Linux terminal, and over here I'm going to fuzz for file, SSH file. So I'm gonna type in dot and then fuzz, and I'm gonna provide in some extension like txt key or HTML. So whatever keyword is going to fuzz for, it will also provide those extension after that keyword and try to find if that file is available or not. We can see a lot of unwanted information here with status 403. Let's remove that code. We can do that with the help of -fc command to filter code 403. And we found something interesting, mysecret.txt file. Let's check this out. And this looks like some encoded data. Probably encoded SSH private key file. But we don't know what is the hash type of this text. So we are going to try to find its hash type from the internet. But before that, I'm going to copy this and save it in a file. I'm going to search for some online tools to identify this hash. And it says could not identify. Let's check out some other website. And it also says not found. So due to some reason I was not able to identify the hash type of this text. So we are going to check another website called CyberChef. Here it is, and I'm gonna literally try every hash type over here. And it seems like it's bits 58 encoded. Since we are able to see the private key over here, let's copy it. And I'm also going to save this in another file. I'm going to call it ssh-key.txt file. We also know that this file is protected by a passphrase. So we need to crack that now. There is a tool from John the Ripper called SSH to John, and if I locate it, you can see it over here in the user bin directory. So this script basically transforms OpenSSH or private key file in a John format so it can be cracked. Here I'm going to provide the key file, which is ssh-key.txt. and then save the result in a file called key. Now if I nano key file, you can see that it's in a different format now. You can see some dollar signs over here. So yeah. Now we need to crack it with John the Ripper. Okay, so do you remember the hint we got from that page that this passphrase can be cracked with fast track file? Yeah, so we have that installed in user share word list. So in a clear screen, I'm going to type in the John command. As you can see, I'm in my Medusa folder, and over here I have this key file, which is the formatted file by SSH to John script. Here I'm going to provide in the word list, which is the fasttrack.txt file, and then the name of the encoded file, which is key, and wait for a while. And we got the password, which is password. Okay. Now we know that port 22 was open, so we can connect to port 22 with these credentials we're given with. So the username was icex64 at, and then the IP address of the target machine, which is 10.0.3.6, and then -i to provide the file, the private key file. And I'm gonna paste this password over here. And for some reason it says permission denied. I get it. It says the identifier file SSH-key not accessible. It's not accessible. The name of the file, yeah, because the actual name of the file was ssh-key.txt. So I'm gonna type .txt, and it says again says permission denied. I think we need to change the permissions of that key file. So chmod 600 ssh-key.txt. It should be fine now. And yeah, we are logged in as icex64. And here is the user.txt file. But we need to escalate our privileges now. So the next phase is privilege escalation. The best way to find possible ways to escalate privileges is by using linps. But before using linps, we should always try to enumerate manually a little bit, so it makes our work easier and requires less time. So I always start with command sudo -l to check for any sudo permissions. And here we can see a command that we can run with the privileges of a user are seen. Let's execute this command. And it says it's not yet ready to get in action. Let's check out the code of this heist.py file. And we can see it's importing a library web browser, and then it's printing a statement, which we saw, and then it's using open argument to open this link, I guess. Let's first find where the web browser library is. So I'm assuming that it might be in user bin path. and it says Python 3.9 is not a directory. A web browser library is not in user bin. Let's change the path. It could be in user lib. And here is a directory Python 3.9. Let's try to grab web browser, and over here we can see the Python file. I'm gonna clear the screen up and nano into that webbrowser.py file. And there is bunch of line of code, and it's importing OS, sys, subprocesses, threading. So let's first check if we have a write permission to this file or not. So I'm gonna type in ls-la grep webbrowser.py. And we can see we do have read, write, and execute permission. Means we can modify this file. And since we are able to modify a library file which is being included in some other file, this attack is known as Python library injection or Python library hijacking. Over here, I'm going to type in a command os.system/bin/bash. What it's gonna do is, when the system will try to run this web browser file, it's going to import all those modules one by one, and when it will come across that os system bin bash code, it's going to execute it and spawn a bin bash shell with the privileges of our scene user. So let's save it. Let's copy that command and type in sudo -u rscene. We want to execute this command as user rscene. So when it will spawn shell, it will be from rscene user. And here we go. We are logged in as rscene now, but we are still not the root user. So I'm gonna type in sudo -l again, and here we can see another command that we can run as root. Pip command. So what we can do is we can find some shellscaping commands for pip in GTFO bins. So I'm gonna head to that website, and over here I'm going to type pip in the search bar. It can be used to break out from restricted environments by spawning an interactive system shell. So we're going to copy this command one by one and paste it in the terminal. It's going to import this os bin/sh in a variable, and then when that variable will be called, it's going to spawn that bin sh shell. We need to run this last command with sudo. So who am I? And here we go, we are the root user now. So the machine I hacked in this video was actually a machine from WebApp. If you want to try that out too, I'm gonna give the link in the description. And if you enjoyed this video, don't forget to like and subscribe.